Welcome back to another episode of the 2JZ RX-7 Drift Build series. Today I want to talk about motorsport fabrication and how to use 3D scanning and 3D modeling to aid in the design process. And today my unique problem that I have is that I've got a 2JZ with a CD009 transmission attached to it, and I need to figure out how to develop a trans mount for this unique application. This is something that others have done before in the past, but there's never been a off-the-shelf product that I could buy to just quickly solve this problem. So I'm going to go into detail in this video on how to 3D scan the trans tunnel and then take that and go into a 3D modeling software to develop a product, and then how to end at a final ready to weld, ready to install product made by a company called SendCutSend. Okay, so the first step is 3D scanning. And the 3D scanner I'm using is a RevoPoint Pop 2, and I like to use this AE-SUB 3D scanner spray. It's a dissolving, vanishing spray that you use on the surface. It helps to lighten up those dark areas so that everything shows up in your model. And then this is the software that I use, and I typically just go to scan and use the high accuracy scan. I use dark mode and no color. A lot of people like to use marker mode so that you can combine multiple scans. I haven't been able to get that to work very well at all. And since I'm underneath the car, it's really dark, I'm gonna use dark mode. And then here, the only thing that I adjust on this screen is really just my depth camera. And I adjust this brightness down until I lose the red. And as soon as I lose the red, I'm ready to roll. So right there is where I would keep it. All right, let's go ahead and get underneath the car and start scanning. Okay, unfortunately, I did not get any footage of me scanning the underside of the trans tunnel because my computer couldn't handle scanning and screen recording at the same time. So this is the final product that we got, and the quality is to be expected, but it will definitely improve as we go along. So really the main gist is that we have our trans mount bushing and these sides of the trans tunnel, because that's where we're going to be connecting to. So the first step here, I took the 3D scan and dropped it into Revo Studio, another software offered with the purchase of this product, and then I go and trim. So if you go up to the poly, you can come up here and you can start outlining things that you want to delete, and it's as simple as that to clean up your product. And then from there, you can simplify. Here we just are reducing the amount of the vertex count, so it's reducing your file size, making it a little bit less reliable. So I typically don't do anything here. I just leave it as large as it is and hope my nice PC can handle it. And then smoothing, you can smooth everything out. Again, you're kind of losing some of the quality by doing that, but you can get away with some of that. Overlap detection, this is a big one. I like to start with large or small and just do either or. So I can preview the small overlaps, delete them, then preview the large overlaps, delete them. And that gets rid of all of the unnecessary overlapping that occurs with 3D scanning. As you go over multiple passes, sometimes it picks up on stuff and bunches it up. Okay, after doing the overlap detection, I like to mesh it. And when I mesh, I do ultra high definition. I do not fill any holes, and I've already done that. So this is what it looks like. You see how the quality has improved significantly, and this is definitely something we can work with. So now that I've got to this stage, I'm just going to go ahead and clean up some of this extra junk here, and we will go into SolidWorks, and I'll show you kind of my first steps in coming up with a trans mount solution. All right, here is our final 3D scan imported as an STL file into SolidWorks, and SolidWorks is definitely my preferred CAD software of choice. I've used this for nearly 10 years now, and I've used Siemens NX, a couple other ones, but this is what I have access to and the most experience in. As you can see, the 3D scan detail is really nice, especially when you add a little bit of texture to it. So I like to add aluminum powder coat to all my 3D scans, and it really improves the layering and just makes it look a little bit more clean. So right here you can see I had cut out the OEM trans mount hump. This is something that got in the way of the CD009. So I'm really starting from scratch here. And because of that, I decided to add some sheet metal to the insides before I put on some additional brackets, which are here and here. So these two brackets right now are protruding outside of the trans tunnel, and that's because of the way that it is bent at SendCutSend, and I'll dive into that more here in a minute. But the final product will be ground so that it is flush to this plate and then welded, and from there it's just a matter of connecting the dots, trying to get from one side to the other and attaching to our rubber transmount here. So the biggest concern now is clearance. I need to fit a 4-inch diameter stainless tube for exhaust underneath this thing. So that is why the transmount ended up being so bent like this. So it's a little odd shaped, it's a little weird, but it provides the clearance that I need to fit this 4-inch diameter exhaust and keep it above the frame rails, or just slightly below. It'll be pretty close. We'll see. So this is the final product. We're ready to get this over to SendCutSend, and I'm going to show you real quick how that process goes. So the first part that we're going to talk about is the bracket that gets welded to the inside of the transmission tunnel. And this is a good part to use as an example for how to submit to SendCutSend, because there's a lot of guidelines that go into making this part. So this is the face that will be welded to the inside of the transmission tunnel, and we've obviously got some weird angles here. So if we were to try and flatten this piece and provide a DXF file for it, we'd have this. So this would not turn out right. We cannot 2D laser cut something like this. So I have to remove that. So in order to have SendCutSend make this, I'm removing the cut extrude, and this is my flat plate now. So I'm just going to by hand cut that off. And this is a big part about using SendCutSend as a service, is not everything that you get from them has to be some perfectly fit up product. I use a lot of their services just to get me really far in the fabrication process so that I can do the rest little important features by hand to make sure that my fit up is perfect. So let's go over some of those guidelines and where to find them. So on SendCutSend's website, under the resources tab, you can go to the guidelines here and read up about what it is you're asking them to do. So the more difficult stuff is bending. And for bending, a lot of what I get tripped up is with die line considerations and with U-channels. So this is a perfect part for that because it hits on both of those. And where you can find more detailed information on this, for example, for the part that we're making, this is a metal, and it is a mild steel, and it is 0.187 inches thick, HRPO. Down here at the bottom, it displays some of the considerations for bending. And right here, it says the die width, which is 0.984. And if you go back to our SolidWorks model, and we flatten this, we can see here, I could sketch a square right now to check 0.984 and make sure that 0.984 was appropriate enough of a width to capture all the material that needs to be bent. And unfortunately it's not. It's really close though. And SendCutSend's awesome software actually catches that. So when I go and upload this into their website and add the material type 0.188 and bending and save it, it actually tells me that this is a caution area because my die width is larger than the amount of material I'm providing. Luckily, it's only a tiny little corner, so this works out well. But you know, here we can see that we've got our bend angles correct, we've got our directions correct, and we're all set up to go. So this is how you kind of get into the uploading process, selecting your material, making sure that you go over the bending guidelines or laser cutting guidelines to make sure it fits their requirements. Okay, so the last part we're going to cover really quickly is just the transmount itself. And for this one, I want to cover a little bit more about the sheet metal function. And for this part, it's really crucial for any of your bending stuff that in your CAD software, you go ahead and set up all of your sheet metal parameters according to the website. So if you go to SendCutSend's website, you go back to your material type and thickness, they have all of this information in here. They have the effective bend radius, the K factor, and you just take that information, you plug it right into SolidWorks or your CAD profile, and it's already in there for you. So everything is exactly as it should be when you go to export it as a DXF. And to export it as a DXF, it's very simple. Gonna export it like this, and we make sure that we are in the appropriate view, and we do it as sheet metal. We go to bend lines. Definitely have to make sure you have your bend lines in there, and that's our flattened pattern with the bend lines annotated. And what we're left with is everything that we need for a trans mount to be fabricated ourselves, or finish fabricated. Like I said, I use SendCutSend a lot for just getting me way further along in the fabrication process. But yeah, $65 and you have yourself a trans mount that you can fit up, weld up, and be for a totally custom application. So it's been exactly 6 days since the day that I submitted the order online to the day that I received it. And really, that is pretty dang good. The more features that you add, like countersinking, tapping, powder coat, it all is going to add more time. But really, if you just do your planning right and you have everything, you know, pre-organized, you can really utilize a service like this to get ahead on your projects. So now let's go underneath the car and see how things fit. All right, this is the moment of truth. So far, so good. So we got a nice amount of give, so we can kind of position that how we want. And then these are the pieces that'll get ground down on the sides. It's gonna be a tight fit, but it should do. So it looks like it fits up pretty dang well. I've got really tight clearance here and here to where I'd have to modify this a bit. But then I realized my engine's maybe a little crooked. So I need to offset that a little bit, since I've had this engine out since the original scan, actually. So yeah, that'll help. I'll just be able to clean up this corner by pushing the trans over to where it actually is supposed to be. And then these need to get ground down by hand to match whatever that angle is, and get welded to these plates that SendCutSend also provided. So yeah, this is going to be pretty decent. It should be a pretty quick job. For anyone that wants to copy, this is a very generically used trans mount bushing, and it's energy suspension part number 1270. So I can't remember what engine that's originally from, or transmission that's originally from, but very common to use. So this bolts right up to the CD009 trans. All right, so the trans mount fits, but I think I'm gonna hold off on final welding and fabrication for that until the engine comes out for its last time, because I do have some rust that I need to fix on the frame rails. I wanna plug up some of the holes and do last final fit and finish on the engine mounts, because those were excessive manufacturing mounts that were modified just slightly to lower them down closer to the steering rack. So once all that's done, I think it would be the most appropriate time to go ahead and do the final welding for that trans mount. And the purpose of this video is really just to show you my process in using CAD and 3D scanning to move forward with your projects, and then using an outside source like SendCutSend for producing them. And I've used that whole process for so many things on this car already that I'll highlight here, like the fuel pressure regulator on the firewall, the idle air control valve, the whole front assembly here for the radiator and intercooler, and the entire fuel cell. So, I really encourage you guys to look into CAD and finding a software that works for you and start implementing that into your fabrication process. All right, so with that, we're gonna call the video here. If you have any questions related to the 3D modeling, 3D scanning, or using the service SendCutSend, feel free to drop a comment below and ask away. Don't forget to use my code Heinz15 for 15% off. See you next time.